This recording is going to be a double lesson, so I'm going to try to keep the video as reasonably lengthed as possible. This is for 7.2 and 7.3 reteaching. In-person people, this is going to be two separate foldables. Virtual people, this isn't going to be on the same document like you're looking at right here. Okay, so 7.2, similar polygons have corresponding angles that are congruent and corresponding sides that are proportional. An extended proportion can be written for the ratios of the corresponding sides of similar polygons. So here we have, are these quadrilaterals at the right similar? And if so, write a similarity statement. So comparing the angles, you can match up the same number of curves in the angles and see that all the corresponding angles are congruent. So the question here is, are the corresponding sides proportional? So they set these up in ratios, 6/3, 8/4, 9/4.5, and 4/2. And they saw that they all did reduce to 2, which means, yes, they are proportional because they're reduced to the same ratio. Okay, so for our exercises here, this says then once we know they're proportional, then we need a congruent statement. So you can write the first one in any order you want to, and then the second one in the same order. We practiced this when we did congruent figures. So for the exercises, if the polygons are similar, write a similarity statement and the extended proportion for the ratios of corresponding sides. We first of all need to make sure we understand the symbols different between equal, congruent, and similar. So let's go ahead and draw those out here. Equal, congruent, and similar. We're dealing with similarity, so the similar symbol for this section. So the equal symbol is, of course, what you're used to seeing. An equal symbol compares values. A congruent symbol effectively means the same thing, but congruence compares objects, not actual values and measurement. Similarity symbol is just the squiggle, okay? So really, the congruent symbol is a blend of the equal and the similar symbol. In order to be congruent, they first have to be similar, and then exactly the same size. All right, so now that we've established that, let's look at these exercises. Okay, so we're looking to see if they are similar. First of all, we can see that in number 1 here, the corresponding angles are in fact congruent. So we need to look at the ratios and see if they are congruent. So corresponding sides here, we have 30 and 18 corresponding sides. So we're looking at 30/18. Okay. And then we have 60 and 36 for corresponding sides. So we're looking at 60/36. And there's many different ways to do this. So if you're looking at videos or watching tutorials that are different than this, they're probably right also. And then we have 40 and 24 as corresponding parts. Okay, so then we have 40 and 24. So we are going to reduce these and see if these reduce to the same fraction. Now you could just divide out these fractions and see if they come out to the same decimal, or you could reduce them and see if they turn out to be the same thing. So I can see that I can reduce 30 and 18. Both of these are divisible by 6. So this reduces to 5/3. Okay. The greatest common factor of 60 and 36 is 12. So this also reduces to 5/3. And the greatest common factor of 40 and 24 is 8. So this also reduces to 5/3. So I can see that, yes, these are all the same ratio. So yes, this is similar. And we can write a similarity statement. Yes, similar. I think I need to recalibrate this pad. Okay, so I need to write one of the triangles in any order I want to. I could probably type this. Let's take this first one and say RQS. I can say triangle RQS is similar to, and this is there is a symbol for this on your keyboard. Actually, it's Shift and the key just to the left of the 1 is similar to, and in the same order, I will say LKM. RQS is similar to LKM. And if you wrote the first one in a different order, then your statement would be different. You could say SQR similar to MKL. It has to be in the same order, just like when we did congruence. Okay, so I'm going to switch colors here. And looking at 2. These triangles are not situated the same way, and I can see that based on the number of curves on the angles. Okay, so I can see that A corresponds to the X, and because they have single curves. And then I have a double curve on B and a double curve on Y. So the side that shares the single and double curves for this one is 20. The side that shares the single and double curves here is 14. So those are going to be corresponding sides, 20 over 14. Okay, and then I have the side that shares the single and triple, 40 here. Single and triple here is 28. So I have a ratio of 40 over 28. Okay, and then my last ratio here is going to be the side that shares the double and triple curve, which is 30 over 21, sorry. Notice that my numerators all come from the same triangle. You do need to be consistent when you're writing your ratios here. Okay, so I am reducing these. 20 and 14 are both divisible by 2, so this reduces to 10 over 7. Okay, 40 and 28 are both divisible by 4, so again this reduces to 10 over 7. And 30 and 21 are both divisible by 3, so again this reduces to 10 over 7. And I can see that all three ratios are the same, so again, a number 2, yes, these are similar. I'm going to start typing because this pen is so terribly slow. Yes, similar. Okay, so I'm going to write a similarity statement. I'll write that first triangle in any order I want to. I'm going to say ABC is similar to. So writing the other one in the same order, I'm going to count the curves. A had a single curve, so I started with A. So I'm going to start with the single curve here, which is X. B had a double curve, Y had a double curve, and C had a triple curve, and Z had a triple curve. So ABC is similar to XYZ. All right. So on 3, here I can see that all of the sides on the square are 6, and then I have a rectangle on the other one. So since 6 over 8 is not going to be congruent to 6 over 4, then no, these are not going to be similar. So for 6 over 8 is not equal to 6 over 4. If I'm looking at corresponding sides here. Corresponding sides. Okay. So no, not similar. Not similar. Okay. And we're looking at number 4. We do not have all of the corresponding angles congruent. 60 doesn't equal 90. Corresponding angles not congruent. So not similar. Okay? All right, moving along. Here we're looking at scale factor. This is what's the value of X. Okay, so here we need a corresponding pair of sides to compare here. And I have a similarity statement to use here. RST. RST is similar to UVW. So these are situated in the same way. So I can see that 4 corresponds to 2. So 7 is going to correspond to X. So they've written a proportion down here, 4 over 2 equals 7 over X, and cross-multiplied to get that X is 2.5, or 3.5, sorry. So the scale factor then is a set of corresponding sides set in a ratio together and then reduced. Okay, so the scale factor is 4 to 2, which reduces to 2. Okay. All right, so your exercises down here, give the scale factor of the polygons, find the value of X, and round the answers to the nearest tenth. Okay. So we're finding a scale factor first. Here I have A, B, C, D, similar to N, M, P, O. These are not situated the exact same way. I am going to use the side here on M and P, O. That is a whole number, MP. MP I can see are my middle 2 letters here, so they're going to correspond to BC, which is 5. Okay. The other piece I'm going to be working with here is X, which is PO, and that's going to correspond to CD. And notice I'm using my similarity statements and the order of the letters to see what's going to correspond to what. Okay, now I'm going to start from my first figure. okay, and put it over its corresponding part, 5 over 3. That is my scale factor, okay? That's my scale factor. And I'm going to set that equal to the other number that I'm using from that same figure that the 5 came from. So 6 over and its corresponding side, which is x. And I'm going to cross multiply to solve that. Okay, I'm going to make note here that 5 over 3 is my scale factor. That is a set of corresponding sides from a figure. Okay, so when I cross multiply here, cross multiply, I've got that 5x equals 18. So I'm going to divide both sides by 5. I feel like we had a problem very similar to this in class today. Okay. 5 goes into 18 3 times with 3 left over, so it's 3 3/5, which is the same as 3.6 is what we get for x. Okay. All right, we have another problem like this. I'm going to go ahead and change color. Okay. All right, so on number 6, I have a given side on the second triangle, which is 10. 10 is on FE. FE, those are those first 2 letters. So that's going to correspond to XY. XY is 15. So that's how I know that 10 corresponds to 15, which means that X, which is DF, is going to correspond to ZY, which is 14. So when I write my proportion, I'm going to start with the figure on the left and put it over its corresponding side. That's my scale factor. Now I'm going to reduce that because I can. If it's reducible, reduce it. 5 and 10, or 5 goes into 15 and 10. So this is going to reduce to 3 over 2. Just divided top and bottom by 5. Okay, so this is my scale factor. I'm going to set that equal to, the 15 came from the left figure, so 14 will go on top. And its corresponding side is x. And then I just need to cross multiply to solve. Okay, I need to make note of my scale factor. Okay, and I'm going to cross multiply this one to solve it. It gives me 3x equals 2 times 14, which is 28. So to divide both sides by 3. Okay, 3 goes into 28. 9 times, because 9 times 3 is 27. So I have 1 left over. 9 and 1/3 is 9.3 repeating. Okay, either of those values is fine. 28 over 3 or 9.3 repeating. Just like over here, 18 over 5 is a perfectly fair answer. It's just in an improper fraction. Okay, on 7, we are looking at the only value that we have on the quadrilateral on the right, which is 9.8. It's on RS. So I'm going to go to my similarity statement. R and S are the first and last letters. So I can see that's going to correspond to LO, which is here. So 14 corresponds to the 9.8, so presumably ST will correspond to NO, and it does. All right. Okay, so my scale factor then is 14 over 9.8. Decimals and fractions are not pretty, but sometimes they are what they are. And you could divide that out if you wanted to. 14 divided by 9.8, whatever that is, would also be your scale factor. I'm just going to go ahead and set that up in a proportion here. 14 over 9.8 equals 11.5 over x. Notice that I am pulling from the same figure when I'm on the same level of the proportion. For instance, 14 and 11.5 came from the same figure. 9.8 and x came from the same figure. And in my individual fractions, I'm using corresponding sides. 14 corresponds to the 9.8, which is what I discovered using my similarity statement. Okay, so I'm going to note my scale factor here. Okay, and then I'm going to cross multiply. All right, so I've got 14x equals 11.5 times 9.8. I wonder if I have that calculator up. Probably not, but I can bring it up. Here we are. What were my numbers? 11.5 and 9.8. 11.5 times 9.8 gives me 112.7. 112.7. 2.7. So all I need to do then is divide both sides by 14, and I have my magic answer. Divided by 14 gives me 8.05. That's not bad. Okay, so my x value here then is 8.05. I do hope that you guys are listening and watching when you're doing these videos and not just fast forwarding and getting notes down. There are some valuable things to be learned from what is said and done in these videos before anything is crossed out. So please, please take the time to listen to them, which you won't hear if you aren't listening to them. Okay, I'm going back to blue. All right, on number 8. See, I have a couple of numbers here and an x. So let's take one of these numbers. Let's take a 20. That's all we got. QR, 20 is on QR. QR, that's the third and fourth letter here. Third and fourth letter. Third and fourth letter here is IJ. So the 20 is going to correspond to the 15. All right. The X is on RS or SR. SR. 1, 2, 3, fourth and fifth letters. 1, 2, 3, fourth and fifth. So that's going to correspond to JK. I'm sure you probably could have already guessed that. Whoops. I did not mean to just cross right through that number. 9. Okay, so I know that X is going to correspond to the 9. So when I write my proportion, I'm going to start with the figure on the left, which is 20, and put its corresponding side underneath it, which is 15. Okay, then notice that I'm going, this time the X is going to be on top because I am pulling from the same figure. It's going to be X over 9 because that's its corresponding side. Now notice that 20 over 15 can be reduced, and I should do that before I write the second fraction. Okay, so 20 over 15. These are both divisible by 5. So this reduces to 4/3. That's my scale factor. Okay, so 4/3 then is equal to X over 9. Oh, I see a pattern here. Those of you that have been in class with me know what I mean. Scale factor. Okay, so what I mean by a pattern, and I'm going to go ahead and switch colors on this so that you can see what I'm doing. Throw some red in here. Okay, pattern, a multiplier. So I'm looking at number 8, and I can see, oh, my denominator's here. I could just multiply this 3 times 3 and get 9. So if I do the same thing at the top, I'll know the value of X, and I don't even have to cross multiply. 4 times 3 is X, so X is 12. There you go. Oops. Ooh, what a terrible looking 12. That's a little bit better. All right. Saving. Moving on. Okay, 7.3 says, are the triangles similar, and how do you know? And it wants us to write a similarity statement. This is really about the proof process. So this says determine whether the triangles are similar. If so, write a similarity statement. Name the postulate or theorem that you used. Okay. So we're looking for similarity here. Notice that the angle-angle similarity postulate can be used, and the side-side-side similarity theorem can be used. There's a couple of others. Ooh, that's ugly. Okay, so looking at number 1, I can see that I have an angle-angle situation because the 30s correspond and the right angles correspond. Okay, so yes, these are similar, so I can write a similarity statement. Yes, similar by the angle-angle similarity. Oops. Okay. So my similarity statement, I'm going to write the first one, ABC is similar to, A is where the 30 was, so the 30 is on Z in this one. B is where the 90 is, the 90 is on Y. And C is the other one, and so is X. So ABC here is similar to ZYX. I hope that didn't trip you up. Okay. And that's all they want us to do there, right? Write a similarity statement, name the postulate or theorem used. The postulate or theorem used here, by the way, is angle-angle similarity. Okay, so on 2, we first need to make sure that we have the corresponding ratios the same. Okay, so I have 8 over 4. 8 over 4 is 2. Okay, I have 10 over 5, which is 2. And I have 13 over 6, which is not 2. So, since all 3 pairs of corresponding sides are not in the same proportion, then they are not similar. Okay? Not similar because all pairs of corresponding sides are not congruent, or are not in the same ratio. Let's say that. Okay, all pairs of corresponding sides are not in the same ratio. All right. Well, if I'm not going to change color, then I'm going to need to draw some lines between these problems. All right, looking at number 3, I can see that 1/2 equals 1/2. So yes, I can see that I do have corresponding sides that are going to be in the same ratio. Okay, it doesn't matter what the values are. Okay, these are equilateral triangles, and all equilateral triangles are similar. We can go ahead and answer 7. Yes, by the side similarity. Okay. All right. So we can go ahead and answer 3 then. Yes, similar by the side similarity. And we can write a similarity statement for this one. We can say QEU, that's weird. QEU is similar to. And I don't guess it really matters. You can put it in any order you want to. I'll just say SIO to be normal about it. Oh, goodness. Maybe I'll say SIO. QEU, similar to SIO. Okay. So looking at 4, I'm going to need to do a little bit of math here. I need to find that third angle first. So triangle sum theorem. So I'm going to say 20 plus 50 plus angle C equals 180. Okay. 70 plus angle C equals 180. So angle C equals 110. Okay, so since angle C equals 110, we can see that we do have all corresponding angles congruent, because if this is 20, 50, and 110, and you got a 20 and a 110 here, that means this one's also going to be 50. Okay, so yes, these are congruent. I'm sorry, not congruent. They are similar. Similar by the angle similarity. So for a similarity statement, I can say ABC is similar to, A was on the 20, R is on the 20, B is on the 50, S is on the 50, and C and T are on that. Okay, so ABC is similar to RST. All right, on 5, I can see that 4 over 2 equals 6 over 3, but the angle between them is not the same, okay? So if I'm using this included angle, then I would have to use this included angle, and I don't know what that is. So there's not enough information here. The 70's in the wrong place. '70 is in the wrong place in second triangle. Oops. So not enough info to prove similarity. Okay. And on 6, I can see that I have one angle, and then I have 2 pairs of corresponding sides that are in the same proportion. So I'm looking at a side angle side similarity here. So this is, yes, similar by the side angle side similarity. And we'll talk more about ways you can, all the different ways you can prove similar triangles. Okay, so we're going to say triangle ABC is similar to, and this is going to be QXR. ABC similar to QXR. You could have also said QRX because this is isosceles. Okay, now all isosceles triangles do not have the same vertex angle, so they're not necessarily all similar. So for 8, are all isosceles triangles similar? No. Only if corresponding angles are congruent. So what this is saying is side is not enough information to prove similarity. Are all congruent triangles similar? Okay. So all congruent triangles, are similar because all corresponding angles are congruent, and corresponding sides congruent with ratio, oops, of 1, okay? But all similar triangles are not necessarily congruent. They are only congruent if the ratio of sides, or scale factor, is 1. Okay, I'm going to draw a couple lines here before I slide off into this next page. All right, and last page, by the way, because this was all the same color up here. I don't want anyone to get confused. Spray nuts, we don't confuse that easily. Some of you might. All right, saving. So we only have one more problem down here because we're not really formally doing proofs. So this last one down here says use the reasoning process to prove the triangles below to be similar. Okay, so I have 3 pairs of corresponding sides here, and I actually have a pair of vertical angles, but we can work towards using side, side, side here. We just have to know what goes with what, okay? Biggest goes with biggest, smallest goes with smallest. So the biggest side, let's make some notes here. To match up the sides corresponding. Biggest with biggest, smallest with smallest. Okay. So the biggest side on AEB is 15. The biggest side on DCB is 5, so those are going to match up. Okay, the smallest side is 10 on this left triangle, and the smallest side is 3 1/3. Okay, and that gives us 12 going with 4. Okay, all right, hopefully you know, well, doesn't matter. Okay, so I have 15 over 5. Okay, does reduce to 3 over 1, or 3. I have 12 over 4, does reduce to 3 over 1. And I have 10 over 3 1/3. Okay, let me pause here just for a second. I want to make sure that you know that 15 over 3 reduced into 3 means that 3 times 5 equals 15. 12 over 4 reduced into 3 means that 3 times 4 is 12. So if 10 over 3 1/3 equaled 3, that would mean that 3 times 3 1/3 would equal 10, and it does, because 3 times 3 is 9, and 3 times 1/3 is another 1. 9 and 1 is 10. Okay, so these do all check out. I'm hoping that some of you have retained some fraction sense and understand what I said just there. All right, so because all 3 pairs of corresponding sides are the same ratio, then we can prove similarity. We can prove similarity using the side, side, side similarity theorem. And we can make a similarity statement. We can say AEB is similar to. So A is between 10 and 12, so it's going to be D, goes with it, okay? E was out here with the line in the circle, so that goes C, and then B is in the middle. There's our last similarity statement. I hope this has been helpful. I'm sorry it's rushed. I just didn't want this to last super, super long. Okay, so please make sure that you get all of the notes down. You can always rewind, go back, do whatever you need to do to make sure that you have got all this in your head, and we are going to work through practice in class together. And virtual students, you'll need to work through the practice and submit it for a homework grade. Thank y'all.